So in this video, we are going to discuss about left shift operator, the right shift operators and 1's complement. So to do that, the operator that is used to shift the data by a specified number of positions towards the left side is called the left shift operator. Syntax: B equals A left shift operator num. First operand is a constant or variable, and this is the left shift operator, and num is the second operand or constant, it can be variable, where the first operand is the value to be shifted, second operand specifies the number of bits to be shifted. So for example, in the statement B is equal to 5, 2 less than symbols 1, the data 5 is shifted towards the left by 1 bit position. Then the result is stored in the value of B. So the binary representation of 5 is 101, and we have 5 zeros here. Once you shift this 0 out, so what happens? 10 comes inside. So then you will going to get 1010. So the value B. So 0 is appended at LSB. So now we are going to show how it will going to work now. CLR is here, int a comma b, a is equal to 5, so a is equal to 5, so b is equal to a left shift operator 1 bit, so it moves left shift by 1, so b is equal to 10. We have to get this. How? We are going to see a is equal to 101, so it shifts the value of bit by 1, so the 10 is deleted and 10 is appended here, 1010. So 1010 means b is equal to 10. So that is how you are going to get. So first 5, the binary representation of 5 is 2, 2 2s are 4, 1, 2, 2, 1 0, 1. So 101 is the binary operation of 5. The 10 will going to be 2 5s are 10, 0, 2 2s are 4, 1 remainder, 2 2 1s are 2, 0 is the remainder. So the binary operation for 10 is 1010. So printf %d left shift operator 1 bit, so that will be equal to %d\n, which is equal to a comma b. So gets here function. So 5 output is 5, shift the bit position by 1, which will be equal to 10. So left shift by 1 bit is multiplied by 2. So therefore 1010 will be equal to 0 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3. So 2 to the power of 0 is 1, so 1 into 0 is 0, plus 1 into 2 to the power of 1 is 2, plus 0 into 2 to the power of 2, which is 0 into 4 becomes 0, plus 1 into 2 to the power of 3 is 8, so that will be equal to 10. So this is how the bitwise operator will going to work. Then we go for the right shift operator. How does the right shift operator works? It is exactly the similar as to the left shift operator. Only thing is it is only appends from the left side and bits towards the right side. Then the operator that is used shift the data by specified number of bits position towards the right side. So that is what he says. So once he says that, so syntax B is equal to a 2 greater than symbols num. So B is the first operand, constant or variable. So this is the right shift operator, and num is the second operand, which is again constant or variable. So where first operand is the value to be shifted, then the second operand specifies the number of bits to be shifted, and then B is the first operand, the value to be shifted B, which is equal to 10 is right shift operation, the value to be number of bits to be shifted is 1 bit. So then 10 B is equal to 10 double greater than symbol 1. The data 10 is shifted towards the right side by 1 position, and the result is stored in the variable B. So if you are considering that, so here what happens? LSB is discarded, 10 is discarded here, and 10 is added here, so it becomes 101. So what is 101? So it becomes 5. So bitwise, the program showing the bitwise right shift operation includes dive.h and conio.h. So we have void main, CLR is here, int a comma b. So a is equal to 10. The representation of 10 is the right shift. So B is A is greater than two greater than symbols are bitwise, that is the right shift by 1 bit. So here percentage d slash n a comma b. So right shift 1 bit is divided by 2. So b is equal to 5. So how you are going to get the value of a, that is 10. 2 5s are 10, 0. 2 2s are 4, which is 1, the remainder. 2 1s are 2, the remainder is 1. Sorry, 0. So the binary operation for 10 is 1 0 1 0. So you will going to get, of course we are going to write that in the end. Again 2 2s are 4, the remainder is 1. 2 1s are 2, the remainder is 0. The binary operation is 5 is 1 0 1 0. 1 0 1. So you can see the binary representation of 10 0 0 0 0 1 0 1 0. So since it is a right shift operation, that 0 is deleted, then 0 is appended here. So 0 0 0 0 0 1 0 1. You can see here you have 4 zeros. In this case you have 5 zeros. This is deleted and appended here. So 4 becomes 5 zeros and 1 0 1 0 becomes, since 0 is deleted, so 1 0 1. So therefore 1 0 1 binary operation, for that b will be equal to 5. They get the final answer, c will be equal to, b will be equal to, that is 10, the right shift operator by 1 will be equal to the value of b as 5. So next, the 1's complement. The operator that is used to change every bit from 0 to 1 or 1 to 0 in the specified operand. Let a is equal to 10. Then after executing the statement, b equals tilde a. So that means the program showing bitwise 1's complement operation. Include stdio.h and conio.h, void main, clr, unsigned char a comma b. So a is equal to 10. So a is equal to 10 means 00 00 10 10. So how you get this? So decimal system to the binary operation. So you're going to get it as 10 as 1010. Then b equals tilde a. So that means you have copy the value of tilde a by 1's complement to copy it into a. So what's changed 0 to 1 and 1 to 0? The value of 0 is here, then it becomes 1. The value of 0 is here, 1. The value of 0 becomes 1. The value of 0 is here, 1. So since it is 1, it becomes 0. 0, it becomes 1. 1, it becomes 0. 0 becomes 1. So that means this is the 1's complement. Then printf, that is within the quotes, tilde percentage d equals percentage d backslash n, close the quotes, comma a comma b. So that means gets a function. So output tilde 10 will be equal to 245. How you are going to get this? So 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 square plus 0 into 2 cube plus 1 into 2 to the power of 4 plus 1 into 2 to the power of 5 plus 1 into 2 to the power of 6 and 1 into 2 to the power of 7. So that will be equal to 1 into 2 to the power of 0 becomes 2 to the power of 0 is 1. So 1 into 1 becomes 1 plus this is 0. 1 into 2 square is 4. So that is 4. 0 into 2 cube, again that becomes 0. So you need not to write. Plus 1 into 2 to the power of 4 is 2 2s are 4. 4 2s are 8. 2s are 16. Then 2 to the power of 5 is 32. Then 2 to the power of 6, 32 into 2 is 64. And 2 to the power of 7, 64 into 2 becomes 128. So when you summing up of all these things, you are going to get the value as 245. So this is how the 1's complement of 10 will going to work. It will be 245. So this is how you will be able to explain the left shift operator, right shift operator and 1's complement. Now we will going to try to solve this problem by showing, we are going to give the demo by using the Turbo C. So to do that, so first we will go for the Turbo C. So first we will go to, first we are going to perform the operation of bitwise. So here the left shift operator. So to do that, so first we will go for include stdio.h, then include conio.h, then void main, then open the braces. We will write CLR is here, of course it is required here. So then int a comma b, then a equals 5, then b equals a less than symbols 1, then printf percentage d less than symbol by 1 equals percentage d backslash n. Here we type a comma b, then we will going to write get ch function and then close this. So when you compile this, of course it's right, executing now, a equals 5. So I want to shift the value of a by 1 bit toward the left side. So b and copy it into b. So printf here 5 less than 1 will be equal to 10. So left shift by 1 bit is multiplied by 2. So that is what we will going to get. So you will going to get this value as 5 into 2, which becomes 10. So that is how it will going to be executed in this program. So now once you do that, so now we go for the second one, how it will going to functions in the right shift operation. See the right shift operator. So to do that, again we go for include stdio.h and include conio.h, and then we have CLR is here, then int a comma b, a is equal to 5 and b is equal to, instead of left shift operator we are going to have the right shift operator here, which is equal to b is equal to a double greater than symbol and 1. So here you have greater than symbol here, and 1 bit we need to move towards the right shift. So what will going to be the function? So get shift and get ch function a comma b. So when you are trying to execute this, of course it is been executing, a is equal to 5. So I want to shift the value of a by 1 bit toward the right side. So once you do that, printf get ch. So 5 is right shift operation by 1 bit, which will going to be the value of 2. So that you will going to get this value, which will be 10 is greater than the right shift operation, shift 1 bit, which is divided by 2, which will going to be by 2. So you are going to get the value as 2 now. So value of a here, what I want to do here is 10. Instead of 5, we are going to take the value as 10, sorry. So here we want to specify insert, so we are going to take 10. So now we are going to execute. So the value you will going to get is 5. 10 is right shift operation is greater than 1, which will be equal to 5, the right shift 1 by 2, so divided by 2 you are going to get 5. So now we want to explain how the one complement will going to work. So to do that, so here first include stdio.h and include conio.h and void main CLR is here. So now we will going to take the unsigned character unsigned char a comma b. So the value of a is equal to 10, b equals 1's complement, the tilde a colon, printf percentage here tilde percentage d, that is the a value, equals percentage d backslash n a comma b and the get ch function. So once you do that, the compilation, so this is the character, so that is why we are using char variable. So printf get ch. So here tilde 10 will be equal to 245. That is how we will be able to get the program right, and the explanation is already given, that is for 1's complement. So this is how the left shift operation, the right shift operator and 1's complement will going to work in the C program. Thank you. So we're going to quit. We'll say no.